Right. Okay, I hope you can hear me. Okay, so right. Right, welcome to another live stream. In this live stream, I'm going to be coding in Blender with Python, and I'm going to continue on a project I have, which is to try and visualize a neural network in Blender using Python. So I'm just going to give you an idea of what I've already done. Okay, so this is very much work in progress, right? There's nothing complete yet. Okay, you can see here the different layers of a neural network, and I've gone up to the point of a fully connected layer, which I'm trying to do. That's the current work I'm doing. Right now you can see the different layers with the convolutions, 2D convolutions, convolution 2D, and max pooling, and so on. Right, so today I'm going to be basically, okay, so this is what you can see. You can see lots of filters, and you can see basically I have an image which I'm applying. You can see here I'm doing basically I've installed TensorFlow in this Blender environment. I've also trained the model which I created in a separate project, and I have also okay, so you can see all the layers here. Let me just show you more what I've done so far. For predict. So this is where I'm visualizing the model. You can see that I'm using, basically the model is trained in the previous steps, and here I'm just doing a prediction with this model, and I'm using this picture here from the nativity, so I can show you the picture. Okay, so this is the picture, and then you can see in here the different filters that the neural network is applying to this picture, right? So it's rescaling. Okay, it's hard to see from here, right? But you can see it's rescaling, then is applying a convolution to the, a max point to the, convolution to the again, and max point to the again, and convolution to the again, and the max point again, and the dropout. Yeah, okay. The dropout is actually an operation that just severs connections between neurons, right? Okay, so, and right now, the next layer I'm trying to do is a fully connected layer. There is like a flatten section that basically takes all these filters. These are like images that have been applied the filter. These are like one channel images, yeah? You can call it grayscale, for internet purposes. Right now you can see grayscale, but later on I'm going to make this a bit more attractive, right? And then it flattens all the basically all the bytes in the picture, right? And then puts it into one massive neural, like it's basically an array of neurons, okay? It's like thousands and thousands. And the challenge I have right now is to try and visualize it in Blender without basically breaking it, okay? And because it requires a lot of memory, okay? And then it requires also the connection. So each neuron can be connected to every other node in the layer that comes next. And that's actually very difficult as well in terms of memory usage. So because you can imagine, right, if you have thousands of neurons and then they're connected to the next layer, maybe it has dozens of neurons, right? But still, right, each neuron can be connected to every other neuron in the next layer. It's very challenging, right? So, but anyway, I'm starting small. So I have another project here. So I'm going to close this. I'm going to open another Blender I have. I'm basically doing things in a way that to make it, yeah. So I'm going to start with a few neurons, right? And then we're going to work out, like this project idea is to try and increase the number of neurons and see if we can scale this. But I still have to work out the geometry. The geometry is complex, and I've spent my last live stream, you can check it, but it's I suffer a lot trying to do even something as simple as trying to place. Okay, I'll show you first what I've done in the last session. I think this is the one. No? Yeah, this one. All right, you can see. Let's go into geometry nodes. Okay, you can see here, right, what I'm trying to do. So I have like, so this is the layer that comes next, right? So you can imagine this is the flattened layer. So it has, okay, here you have hundreds of neurons, but you can have thousands actually. And then each of these neurons can be connected to, will be connected to all of these neurons. And the only difference will be there is some kind of weight attached to it. So the thickness of the connection is going to be different for each one. But let's not worry too much about that yet. Okay, you can see I already have some cylinders here. Let me show you the script. So I have last live stream I've created these connect neurons. This is actually harder than it seems. So the idea of this function here is to specify a coordinate to start. So a coordinate like an origin, like, and then basically connects this location to this location using a cylinder, right? Okay, and that's why you see in this here, you see basically this is an example of a connection that I tried to create. Like right now, of course, I'm not connecting to anything. I'm just trying to experiment. Okay. And to be honest, all these neurons, they are created using an array modifier. Okay, so the array modifier is very efficient because I only have to define one sphere for the neuron, and then you can duplicate that sphere thousands of times, and it's very efficient in Blender, rather than just creating thousands of spheres. That doesn't scale very well. But the only problem I have now is that I don't actually know the exact coordinates. I've been like looking at this API for a long time. The array modifier doesn't seem to give me the exact coordinates of each sphere. So it only gives me the dimensions of the whole array of neurons, right? It gives me the gaps and so on, right? So I'll have to work it out how to, I'll just use some mathematics to work out the coordinates of each sphere. It shouldn't be too difficult, I think, knowing that. Okay, because I spent a lot of time trying to figure out if the API lets me do it or not. Okay, so let's see. Okay, so we have here an array. So these are too many actually, number of nodes. Let me just make this. Let's do 5. I'm going to delete everything. Delete. Then I'm going to run this again. Okay, so it only has like 5 spheres. Oh, there's a script failure. Okay, so Windows System Console allows me to see any errors that I might get. So I have, okay, this might be from my previous experiment. So I have some error in line 58. For line 58. What? 58. So 58 says, okay, this is me trying to experiment with APIs, just figuring out what I can do. Okay, delete that. Okay, and now let's start. And just, okay, so we have here 2 layers, right? This layer has 5 by 5, and this one has 10 by, I think 10 by 10, 10 by 5, yeah? But to be honest, that's... Oh yeah, 10 by 5, okay. So let's do 2 by 2, just trying to keep it simple, 4 by 4. Delete everything again. Okay, and run this. Oh, maybe I'm actually not helping you. Okay, let me explain 1 second. Okay, I saw your question, Sekyum. I will explain it. 1 second. Let me just put the screen in a way that everyone can see it. Okay. Right. So to explain again, right, the goal of this project, I'm trying to visualize a neural network with Blender. Okay. You can already, you probably can check the previous live stream, but I already have done some work, and I've managed to visualize some layers of the neural network. So a neural network has layers, has neuron. So like there's different types of layers, like convolution 2D. You have also max pooling 2D, and then you have also fully connected layers, which is the one I'm trying to do now. So you have different types of layers, and the idea is to try and visualize each type. Yeah. Okay. And right now I'm actually just focusing on the fully connected layer. And in the fully connected layer, what we have here, let me just show. Okay, modeling. So obviously, so in the fully connected layer, right? The goal is, okay, so this is the layer that comes, normally it's from left to right, because the more you go to the right of a neural network, the less nodes you will have, right? Sometimes it's not the case, but in this case, right? So you have 4 by 4. So we have a layer with 16 nodes, okay? And then we have a layer of 4 nodes. And what I need to do, I'm going to use this type of connection here. I'm going to connect each node, so each neuron, to the neurons that come in the layer after, okay? So it's going to be 1 connected to these 4, and then I'm going to do the same for this, for every single node in this layer. And that's why they call it fully connected, okay? And each connection between this node and this node is has a weight, and the weight will have basically as a number between, like, normally it's like 0 and 1, yeah? So it's a thickness. You can think of it as a thickness, right? The connection, how strong the connection is, right? Does that make sense? Let me know in the chat, right? And if you still have questions, I'll be able to answer them. Okay, I'm using Python in Blender, and that's why I'm doing this. Okay, so let's see. So we have two layers here. And we have this function, which I created in the last live stream to connect neurons. And this is a coordinate to start, and this is the coordinate to end. And what I need to do, okay, I know this is an array modifier I'm using. And the array modifier is very efficient, but it doesn't tell me exactly where the nodes are. I need to figure them. I need to use some mathematics to figure out where they are. Okay. So for example, I give the coordinates here of 0, 0, 0, right? If we look here, zero, zero, zero. So you can see, oh, this is, oh yeah, this one is 0, 0, 0. Okay. Hang on. So let's just work it out. Okay, so this one is a small layer, 0, 0, 0. Okay, let's make it, I want to have more nodes on the left. So I'm going to swap this. So 4, and then 2, and then 2. Okay. And then we have the, this is the coordinates. Just going to delete this. Let's run it again. Oh, I have some syntax error. Okay, here. Right, so we have these two. Now, okay. Modeling, modeling, modeling. Okay, so we have, okay, we should see it from this side, right? So this is coordinate. You can see already the issue, right? So if I click here, the coordinates say, this is an object, yeah, in Blender. The object is composed of many vertices, right? Okay. But this is actually using an array modifier in Blender, which basically takes one sphere and then it duplicates that sphere, okay? And then it takes a gap as well. So there's a gap between each object, and we can configure that in array modifier, okay? And you can see the actual object itself, the coordinates, the center of this object is 0, 0, 0, okay? Which is here. But there's no objects that as you can see, there's no objects here. So I need to figure out the coordinates of each of these neurons so that I can use the function that I defined before to connect this neuron to that neuron. Okay, so that's what I have to do now. Because there's no API that gives me that value. I've looked for it everywhere. Right. So we have 4, 4. So we have, let's have a look at these properties here. Okay. Data. So I'm just looking for the array modifier in the UI. Material properties, texture properties, object data properties, geometry data. It's not here. Okay, modifier properties. But it's not really. Okay, it doesn't matter. Like I can see from here anyway. The function I'm defining controls. So it creates a UV sphere here. Okay. and then we use a modifier, an array modifier, and we have an offset of 1.5, and the displace one. So this is in the x. I think this is an x. The x coordinates is 1.5, and then in the y-axis is 0. Okay. So this one is offset displace. Let me see. So we have so 1.5. So this is not going to be very easy because I need to figure out how it's working out the coordinates of each sphere. So I know how big the sphere is, and I can control the radius here. So if I set like the radius to 1, it should be bigger. Let's see, rendering, modeling. Device. What? So it does look bigger, right? Should be bigger. So let me try 10 just to make it even bigger. They are the same size anyway, like, so that's why it's not clear. Anyway. Okay. Wow, it's huge now. But you can see the actual, depending on what size I specify for each sphere. So if I specify, in this case, the radius was what? The radius was 10. So radius 10, it should be 20 times. So we have 20 times 4. Yeah. Let me use a calculator. It's 80. So we have 80, right? So the dimensions here is 110. Using the size of each sphere should be the radius 10. It should be 20 in width, right? Because of diameter. So if I have, well, I specify with gap, right? So 80, so 110 minus 80 is 30. And we have, so 30, so 10, so 1, 2, 3. So there's like 3 gaps, right? Between each, so each sphere has a gap of 10, let's call it, in this case, it's meters, right? So 10 meters gap. Okay. And I can basically work out like a matrix of 4 by 4, and I can work out the coordinates based on this information. So if I specify, let's try and just make no gap. Let's see what happens, play a little bit with this. So I'm going to put the displacement to 0. Yeah. Make it a little bit smaller. I'm going to go back to 1. Delete this again. Oh, what happened there? There's no displacement, so everything is in the same place. Okay, so that's interesting. So if I specify 0, okay, let me try like 1. If I do that, okay, so I have like a very tiny gap. It's interesting that if I have a gap of 1, okay, this have like tiny bit separation. Oh, it's more like an iteration. I see what's happening, right? It's not so much about, this is not like a gap, it's more like an offset. Yeah, as it's saying, it says there actually, offset. So this is actually much easier than I thought. Okay. So for each, okay, this is offset on the y-axis. This one has 0, 0, 0. So if I set an offset like this, yeah, right. So we have, you can see my whole screen, right? Almost, yeah, you can. So modeling, okay, so we have, oh, it went a bit sideways, right? Scripting. So I've specified. Let's just have a look at this property, right? Just to double check exactly what it does. Render. Relative offset displays. Oh. Oh, I see. Okay, I think I understand now this property. Okay, so 1 is basically means It's basically the whole width of the element, right? So the gap, there's no gap in this case. Yeah, so you can see the items are next to each other, right? If I do that for the other axis as well, 1, then so we have, well, that's what I'm not sure I understand. Why is it not? Oh, it's creating a gap in this direction. Okay, so if I want to actually have like the nodes one below the other, so I need to specify also a displacement in the z-axis. Yeah, so like here, so 2. Maybe I'll keep this one to 0. Do it all of this, and then I will just run this again. Okay, and we have modeling. Oh, why we have only 4? Okay, because this one is, I see what's going on. This is how, so I'm creating actually 2. I see. That's how I did it. So 0, 1, 1, and then so I have 2 modifiers. Displacement. Okay, got it. Modeling. Okay, so this is like, okay, it's getting there. Of course, to be fair, I don't even need the gap between these neurons, right? So let's do, doesn't do very well. Doesn't do undo very well, so I need to be careful here. So, wow. So what did I do just now? Scripting 0, 1. Okay. This. Yeah, so one, 0. It's like, I think I'm starting to do some art here. I don't know exactly how I managed to get this. It wasn't on purpose. Texture paint. Right. Everything in a row. I know. Okay. So 0, 1. Okay, I'm going to revert. So ArrayModifier. So I'm doing X. 2, 3, 4. So I'm disabling this modifier for now. I'm a little bit confused. So modeling, okay, so there's no offset, right? So I expect this to be just one big sphere, but this is duplicated 10 times, right? So if I set an offset in the x-axis, right, which is what I think this is, it should show me 4 times. So let's find out if this is the truth. Okay. So modeling should show me 4 times the sphere in the same row. Yeah, nothing complicated. Okay, so this is 4 times. Okay. Okay, if I go back to this script here, and this is where I'm getting a bit confused. So displacement in a 0. So let's try that. Okay. Right. What happens just now? Okay. Seems like it worked, but I'm not 100% sure why. Modeling. Okay. So 4 by 4. It's the same object. And this is 2 by 2. Okay. So I already know if there's no gap, so I can actually easily calculate the coordinates of each neuron because there's no gap. Later on I can add a gap, but right now I don't have a gap, so I can make it simple for me. Right? So how do we do that? Let's try and define a function. What I'm actually returning here is not really useful, is it? This is just a sphere. Basic sphere dot location equal to origin. Okay. Right. So let's do hello. I don't know what that means, but okay. So we have I can actually return, instead of just retaining the sphere, I need to return 2 objects, right? So the sphere, which has the array modifier on top applied. So it has 2 array modifiers. So I can call this actually a layer, a network layer, instead of a sphere. It makes more sense. Neuron layer. So the neuron layer. Okay, and we can, where's the sphere? So I'm going to call this neuron layer. It's actually a sphere which is multiplied n times. Oh, let's call it neuron layer for now. Can call it anything I want. Okay, and then just have to make sure the name is changed everywhere. Number of nodes. Okay, it's all good. Let's try and run it again with a new name to see if it works. So now I'm just returning a single thing. Oh, there's an error. So Windows System Console, where is it? So we have basic sphere not defined. I missed it somewhere. I don't know why this find and replace doesn't work here. It's working somewhere else. Okay, so basic sphere is here. Okay, so neuron layer. Is it basic sphere? Delete, run. Okay, still have an error. Line 40. And it? Yeah, it's working now, I think. Did it? 57. So there's another error in line 57. Okay. Good. Another one. 66. Okay. I have to run this again. And let's see if I got more errors. Okay, now no errors. And I have exactly what I want. Okay. What I'm going to do now, I'm going to return a second. It's going to be a NumPy array with 2 dimensions. So, and this will be the positions of each. Okay, let's call it neuron grid. Yeah. It's probably better that way to call that. Okay, and I'm going to set neuron grid. I'm going to call another function equal to calculate grid neuron positions. Okay. For now, I'm going to pass in. To be honest, I don't really need any of this here, because everything here should be based on what I pass in here. So I know I need I know how many nodes I need, and it's going to be a 2-dimension. So it's a tuple with 2 elements, and then I know the origin. Okay, I don't know the radius because I'm currently hard coding it here, but I can also pass in. I can actually pass in another variable. I'll do that later. For now, I don't want to complicate it too much. So I'm just going to neuron grid. Okay, let's call it calculateNeuronGrid. Yeah, and I'm going to give it an origin, number of nodes, origin, and then let's give it okay, maybe I'll create it now. So this is let's call it neuron. Okay, neuron size equal to 1. Yeah, so it's going to default to 1. So neuron size divided by 2. Yeah. So I know now the neuron size. this is a radius, so I need to make sure it's divided by 2. Okay, and we have now, we have the 2 parameters I need. Neuron size. Okay. Okay, now I can create this method. So this is just going to be a method, nothing. It's only using NumPy. There's not much geometry here to think about, to be honest. I'm actually just trying to fill in a gap in the ArrayModifier API because it doesn't give me the positions of each sphere. So I need to basically guess with some mathematics. It's fairly easy, to be fair. Right. So the parameters are number of nodes. Okay, I'm just going to copy this. Okay, so number of nodes, origin, location. So the origin where the neuron layers are going to be, and the neuron size. Okay. So I'm going to have the number of nodes. I know it's going to be rows and columns, right? So I'm just going to just say, okay, rows and columns equals to number of nodes. Yeah. And then we have, right. So I'm just checking to make sure the sound is all working. Okay, so number of nodes, it's set. Then we have the origin. Okay, and this is where I'm going to say for the locations. So I know the neuron size. That will be a gap. Right now I'm going to assume there's no gap. We can add it later. So the rows times the neuron size, okay, it's going to be the width. Yeah. No, sorry, the height, because rows is like in the vertical, right? So height of is equal to this, and then width is equal to columns times neuron size as well. Okay, we can all adjust that. I'm not 100% sure if I'm getting all the parameters correctly. I'm just making a guess how things are going to work. So I know the height and width are going to be roughly like this. So because we don't have any gap between neurons, I don't have to add any extra padding on top, but I can add it later once we work out the basic method. Okay, so to actually work out the location of each neuron, right? So I need to define the center of this, right? What I know where the origin is, right? Maybe write I'm going to open some diagrams just it's easier to see. Okay. It. Diagram. Okay. So maybe just visualizing. Yeah, let's do. So just trying to visualize what we are coding. I'm not using Blender just so I don't get lost in the 3 dimensions. This is quite ironic. I'm coding for Blender and drawing some in 2D. Okay, right. So this is our box. backwards. Okay. So too bad. Okay. And we have an origin here, somewhere here. Be another. Okay. I don't want to get lost in the technicalities of this, right? But this is the, let's call it the width for now. Okay. And this is the height. Okay. And we all also know the origin, right? So the origin is here somewhere in the middle, right? So this is the origin because it's the center. Because I've made it the center, right? If it wasn't convenient, I could also set the origin to something else. So this is the origin, right? The vertical center. But actually the origin only helps me to create this, draw this box, which is where I'm going to put the spheres in. Because what I really want to know is the location of this one, right? So coordinates 1. Yeah. I want to know these ones because they are the ones that are going to allow me to afterwards connect the neurons to each other. Okay. So how do I calculate the coordinates like this? Yeah. So that's what I need to figure out. Okay. Actually, I can do something 6. Right. So the first thing I can do, right? I have the origin. I know I need to do some kind of square. I can work out the coordinates of this guy here. Right? I should be able to do that. I should be able to work out the coordinates here as well. So divide the height by 2. Okay. So how do I get that? Oh, I see. So divide this by 2 and then divide it again. So I'm going to divide this by the number of neurons. Then I divide it by the actual diameter of by the radius. That gives me this coordinate here. And then I can work out this coordinate by actually checking doing the same process for the width. Okay, so let's do a little bit of mathematics there. Very simple one, I think. Okay. So height. I'm going to imagine everything is, for now it doesn't matter what is the origin. I'll add it later. So height divided by the number of rows, rows, yeah. Okay. So that gives me the row height, right? So that gives me this. So I get this row height, yeah? The row height is basically, for each row, we have the height. Row height. So divide by, so I'm going to get the row height. So that's the row height. And then I can do the same for the columns. So columns, so height is equal to width divided by, oh, what did I do? It just messed up my Blender. Oh man. What? I just pressed something and it's some kind of shortcut. Right. Oh, I press whatever it was. I press it again. Okay. Easy to get lost in all these shortcuts, right? Okay, so width divided by number of columns. Yeah. Okay. So I have the row height and the column height. So for each row, so if I do 4 row, let's call it index, right? So 4 row index in range of, how many rows do we have, right? Okay, I know yeah, we have, of course, we have rows, yeah. So rows of 0 to rows, yeah. Then I can just say the coordinates, so the neuron coordinate is equal to row index times the row height divided by 2, right? Obviously, right? And this is going to be the actual. Okay, we're doing the rows, so it's going to be the y value, right? Okay. The y value. So I have to keep my window open because it's very hot today in London. So I apologize if you hear any background noise. I do live by a train line. This is not ideal, but I rather keep the window open than sweat like a pig. Okay, so all right, so we have the coordinates for the y. The z, I think it's going to be, of course, this is 3 dimensions, right? So I've only worked out for 2D, but yeah, this should be easier on the, this is actually z axis because z is the height, it's going up. Okay. The y is actually going to be something like, it's going to be really easy, I think. It's going to be just the middle. We'll figure it out. Okay, so we have the neuron coordinate for z, okay? So now, for each row, we have, of course, a number of columns, right? So I'm going to iterate, I'm iterating through each row. And then for each row, I'm iterating through each column. Yeah. So for column index in range of 0 to columns. Okay. Right. Then we have then we have basically neuron coordinate. Let's call it x. I'm assuming y is going to be more or less the same for all of them. X is going to be, so column is going to be the column index times the column height divided by 2. Yeah. Okay. And I'm going to say So neuron coordinate, I'm going to fix the neuron coordinate for y equal to zero for now. I think that will be it, right? So return. Okay, so we have to fill in a list. So I'm going to make it very simple. So I'm going to create a list of a grid equal to numpy dot array, and it's going to have two dimensions. So let's just go back to basics. Numpy array. So let's just see the documentation. Array. Okay, let's just look at this one. Okay, so the method I'm using is numpy.array. Okay, and I can pass in, of course, an array already that is there, but actually I want to create an empty array. So okay, so this example is for an array that already has elements. I can do an empty array like with zeros, yeah. So numpy.zeros. Okay. And I can specify two dimensions, okay. So np.zeros. So I'm going to create, what is it? I could use just a normal array, to be honest. I'm just using numpy for practice. Right, so we have number of rows and columns. So that's my numpy array, okay. And so I have, initially I'm just going to have like coordinates of, actually it's not as simple as that. Okay, so for each, okay, it's not like just a 2D. Each row will have three coordinates, x, y, and z. So I need to also specify here 3. So x, y, and z. Okay. And then what I can do now is to say np, okay, neurons grid. And then I can pass in the row index and then the column index. And then I can say equal to neuron coordinate x, neuron coordinate y, and then neuron, it's too much, too big the names, neuron coordinate z. Okay. Just make this a bit more tidy. F. Okay, this is the neuron grid, the neurons grid. I call it neurons grid. All right. It's not that funny, is it? Okay. All right. So we have the locations of each neuron, but I'm pretty sure the first time I do this it's going to be completely wrong, but you know, it's the first stab at it. But it kind of looks more or less, I think it looks okay as a first try. I have, yeah. I'm not even taking it into account. I'm not using origin yet. I will use it later, but I just want to see something working before I before I do anything else. You should always try your code as you write it as soon as possible, because otherwise you end up writing code for hours and hours and nothing works, and then you don't know what is broken. Okay. So neurons layer is going to return me two things. This is the object itself. I can call it object, so it's very clear what it is. Oh, and I'm not going to rename it again, because I had to rename it like 10 times. Right, and then so the object, and then actual a numpy array. Okay, and I'm going to print it. I'm just going to print and see what is the result. Wait, one. Read 2. Okay. And I'm going to print this. So neuron grid 1, neuron grid 1, and then I have neuron grid 2. Yeah. And I can see what kind of coordinates I've come up the first time, you know. and hopefully I'm sure there'll be syntax errors, things that are going to fail, so I just have to go through those errors one at a time. Okay, so I can see there is already errors. So let me just open the system console. And before I forget, save it again. You always have to save in Blender, because you never know when you're going to crash it. And when you crash Blender, it's not a good feeling. I've had it before. I lost all my code. Okay. Okay, so I have some syntax error on line 6. Yeah, line 6. Oh. What is line 6? Surely. This one is the pair. Okay. So invalid syntax, line 68. Line 68. That makes more sense. I don't need this. Line 68. Did it say 68? 68. Right. So 68 is saying create UV sphere. Okay, I'm supposed to divide by 2. I don't know why I didn't complete that. Okay, now I'm going to run it again. Okay, I'm going to delete everything before that, so I don't end up creating a massive list of objects. Okay, so we have another error as expected. So line 226, I didn't close some brackets or something. Oh, these curly brackets, I didn't close them. So it's 226. This is actually my debug code. Feel free to ask any questions and interrupt me at any time you want, you know. Okay, so I have fixed that error. Let's see what comes next. Another error, I guess. Neuron grid 1 not defined, 226. Oh, neuro grid again. I missed the N. Delete. Yeah. Right, so next error. Oh, I got some results already, more quickly than I expected. But then I'm looking at it. Okay, you can see the X is moving up. That's good. But then we see the other coordinates are static, so there must be I must have made a mistake. Okay, let's see. So neuron grid, column index. Oh, what is call height? There's no such thing as call height, right? Call width. Yeah. Okay, so but then that doesn't explain my error. Okay, I can see that this is actually moving. It's this one that's not moving. Why? So Z. Oh. X, Y, and Z. But so Z is always the same, right? It doesn't move. Oh, it does move actually. So these are 4 coordinates for the first row, right? Then we have second row, third row. Not sure. Okay, let me think. We have the dimensions. Oh, to be honest, I wanted to actually add a label so I knew what I was looking at, but I didn't do that. And I was duplicating the arrays twice. That's why it was a bit confusing. So I've just fixed that. Going to delete it and run it again. Okay, and we have a neuron grid 1. Okay, this is much easier to see. Okay, we can see that we have one, two, three, 4 rows, and then for each row we have 4 columns. That's what we expect, right? So the first row is starts at 0, 0, 0, then 0 0.5, 0, 0, 1, 1.5. Okay, that makes sense. Of course, this is the origin, right? I'll need to figure out later on how to calculate the starting point properly. But I think this looks okay, right? So this is the first row. So I expect the Z to be the same, and then the second row. I think that I've made a mistake here, because the second row should be, if the radius is 0.5, then the gap between each row should be 1 at least. But I have 0.5 here, so I have a mistake there. So neuron size. For my neuron size is what? It's going to be neurons layer, neuron size. It's 1, right? So in this case it's 1. Oh, I see. I'm actually passing 0.5, so that's okay actually. So the results I got here, they should be correct. So I'm moving like within half a meter. I'm using meters for now in Blender, but you know, you could consider these centimeters, whatever you want. So 0.5, so 0, 0.5, and 1, and 1.5. Oh, no, that shouldn't, that's right, that's wrong. So the neuron size is actually 1. So 1. So what's the height? The height is the rows times the neuron size. So I'm a bit confused because I must be passing the wrong value somewhere. Okay, I think I know what it is. So if I go into here, oh yeah, here. Okay, I'm passing neuron size. It's 1. So neuron size. I'm dividing the row height by 2. Oh, I see. I got it. So if row index is 0, this is going to be 0. If row index is 1, this is going to be 0.5, and so on. Okay. So it's okay for the first one, because if this is row index equal to 0, this is, no, actually this is even wrong. This is not even right. Okay. So starting, there should be like starting plus, yeah. So start x. Yeah, and for now I can consider start x is going to be equal to row height divided by 2. So start x, okay, let's imagine it's 0.5. Then we have row index is 0, so the first one is going to be 0.5. Then if I say row index is equal to 1, then the second one is going to be 0.5 plus 0.5, 1. So it's still not right. So I should be doing row height actually. So I don't need to divide it by 2. Okay. Right. And this is where later I can actually adjust this to be the real starting point for x. I don't know yet for sure. So, but it's important to make sure that the actual gaps is correct. So we have start x, and I can also create the start y, yeah, to start z actually. Start z equal to, oh, I'm confusing. No, I'm just completely mixing everything together. This is start z, okay, and then row height is okay, and then start x is equal to column width divided by 2. Yeah, and I can fix the same, it's the same issue here. So start x, start z plus column index times column width. Okay, and we have the coordinates correct. Now they should be correct. Let's have a look and see if it's what we expect. And then, okay, and we see here now that Okay, make sure first of all. Okay, we have. Okay, this is correct now. So 0.5, that's a starting point for x. Okay. Then 1.5, 2.5, 3.5. And then the z is the same because we are in the same row. And then, okay, this is how is exactly what we want. Okay. So I think I have the function working. But now I need to fit in the origin, because the origin, okay, if I look here, this is the origin. And based on this origin, then I guess I can draw a rectangle, right? And calculate the coordinates. Based on that rectangle, I can figure out where to... So this origin will allow me to draw like an imaginary rectangle based on the row, on the height and the width. And then once I have the rectangle, I can actually work out these coordinates quite easily, right? I can justify this by the number of rows. Okay. Okay, I see. Let's do something simple, right? I have the origin. I can calculate this point here. I can derive this point, derive point. I can call it something like, maybe we can call it what? Derive point, let's call it top, yeah? We can get the top. We can derive the point, the bottom, based on, yeah? Yeah, and then, this is almost like by just, yeah, so I can see this point here as well, derive point left. So I can calculate this point, okay? And then I can calculate this one on the right. If I don't think I need the right, to be honest, but I can calculate it as well. Right, okay. And then honestly, I'm just using very, I guess it's very basic geometry, you know? And I'm just figuring out, okay, how I'm going to get all of these coordinates here, because it's not immediately straightforward. Okay, I can calculate the left, the right, the top, and the bottom. I know that if I divide this this rectangle by the number of rows, then I get the height of each row. And then if I divide that further, I know I can get the actual coordinate here. So actually, it's very simple, right? If I can calculate this point here, I can also calculate this one in the y-axis, right? If I can calculate this point here, I can also calculate this one. Right, this is the middle though. Okay. Yeah, because I know it's the very left hand. Okay. Okay, so let me just give this appropriate name so I can just add this to the code. So point. Okay, let's just do some code. So I have here I'll do it before. So point at the top. I need the height and width, by the way. Okay. So point top equal to, so I know the origin, right, has a, let's just put it here so it's easier to manipulate. Is it the origin has an x, a y, and a Z. Okay, and with that, I can just calculate all the coordinates. So origin Y, so point at the top. So top for us is in the Z axis, right? Is the 3 dimensions. I know the Y is fixed because I've already, it's fixed, for us it's fixed. So we only care about the X and the Z. So point at the top is going to be the origin of Z minus, we know the height of this, right? We know our origin is going to be the very middle. Okay, so if we know that, then I can just say height. So origin of Z minus the height divided by 2 is going to give me this position here. Okay, let me just think for a second to make sure that I'm not wrong. I think that's the right thing. Yeah. Okay, so point top, let's call it Z. I don't care about the Y. Point top Z. Okay. Okay, or we can call it top Z coordinate. Yeah, the uppermost top Z. Yeah, I will call it top Z. It's easier. So top Z, we know how to calculate it, and now top X is going to be the origin of X minus the width, the total width, divided by 2, because we know the origin is in the middle, right? So we can actually say, okay, this point can be calculated in that way, right? So we kind of have these 2 key numbers. So how do I get this starting point? To do that, I guess I can start from here. Okay, I know because I know I'm at the top. I know that I'm just going to have 1 neuron below me, and I need to get the coordinates. So I need to get this Z value, so this coordinate here. So I just have to do, so start Z equal to top Z plus, because we want to go down, right? Plus neuron size divided by 2. Okay. Just start brackets. I know, we know division has precedence, but it's always easier to have run brackets, so you know. Okay, so we have the start Z. Okay. And the start X, I can calculate it by doing the same thing that I've done for the Z. So top, I shouldn't call it top X, right? Because this is, okay, here makes sense, it's top. Left. Okay, let's call it left X. Left X. Then starts, okay, so left start X is equal to left X plus the same thing here. It's actually a neuron size divided by 2. So we have the start X, start Z, and then the Y is always going to be, for now, it's going to be, the origin is going to be based on what the origin is saying it should be. So origin Y. We're not, so our layer is vertical, right? So we're not really going sideways. So yeah. Right, so we have start X, start Y, make it in order, it's easier to see. Okay, and you see this diagram, that's how I calculated it. Just by working out from the the coordinates around the origin. Okay. So we have now start X and start Z. I don't need to have these values used anymore. And then we'll start Y. It's okay. So I'm just going to put start Y. Yeah. Okay. Right. So let's test this. Hopefully this is going to work the first time. I'm saving, making sure that if I crash Blender, I haven't lost my script. Let's go to modeling. Okay, this looks okay. Anyway, that's not what we care. So let's see in our debug. Okay. I'm expecting this to work, but okay, you can see that now it starts to make more sense because our origin is 0, 0, right? The one we set here is 0, 0, 0. This is just to keep things simple, but later the origin can be anything really. Okay, so if we have a row height of, so each neuron is diameter 1, so we have 1, 2. So it's going to be -1 here. Sorry, 1 or -1. I don't know if top is -1 or not, but it doesn't matter. -1, 1, -1, 1. And that's what we kind of, I think we see more. We are seeing -1.5. Because it's 3. Okay, so we have 3. This is just an example, right? So it has only 2 rows, but actually there's 3 rows in fact, there's 4. So 4 rows. I think that's right, but so the second one is easier to see. Okay, this is only 2 rows. -0.5. Yeah, okay. I think this method is working. I think it's already working. But even if it's not working, we'll find out very soon, because I'm going to try and use this NumPy array to connect. Basically, I'm going to use this function that created this connection, and I'm going to try and connect this to this. This is the fun part, actually. Okay. I don't know if this is going to go. Yeah, no idea. I'm hoping it works. Okay, so we have now 2 layers, right? And then what we can do, I'm going to create the connections, right? Connect neuron. Let's call it connect, for now, connect layers. Simple. And I'm going to pass in the layer 1 and then the layer 2. Okay. And I'm just going to define the method and let's see. The layer 2, so neuron. Connect layers. And we pass in the arguments, so neuron layer 1. It's going to be a grid, right? I don't care about the object because I only need to know the coordinates of each sphere. So neurons grid 1. It's not a very nice name, but okay. Okay, so what I can do, So I'll explain what I'm going to do now. So if I go to the geometry in Blender, right, I'm going to iterate through each of these spheres, right? I'm going to get the center coordinates for each one. That's why I was creating that method. And I'm going to iterate, okay, for each one here, I'm going to iterate for all these 4, and I'm going to create a connection to that. So I'm going to do an iteration. And to do an iteration, I can do 4. So this is going to be, we know more or less the shape of this because this is, okay, this is rows. So we have to do for each row. I'm going to do, I'm going to make this even simpler. Layer 1, layer 2. So for neuron, no, sorry, for row in rows in row layer. Oh yeah. I have to think. Okay, so these are the coordinates. Actually, I'm just thinking, you know, do I really need to have a shape like this? Because it's not really helpful, right? So each of these elements is going to be a coordinates for one of the neurons. Okay, I need to flatten this NumPy array actually. Yeah, and there is actually something in NumPy called flatten. Okay. Let me just try and do flatten and see if that works. So np.flatten, just to test it first. So let's delete what we had before. Hey, if you are watching this and you think you are getting value out of this live stream, don't forget to click the like button. It will be very helpful. Oh, my Blender is crashing. Oh, I knew that this would happen. But I'm pretty sure I saved, right? And the question is, did I save frequently enough? Because I'm about to find out whether I saved enough. So I need to cancel this, close the Blender. And as I said, and I wasn't joking, you will crash Blender if you're doing Python scripting because you'll make a mistake or maybe there's a bug somewhere, I don't know. But I am very confident in my saving frequency. Let's see. How much code I lost? Open recent? Yes. Are you there still? Yeah, I think it's still there. Thank God. Yeah, so I haven't lost any work. Thank you. Okay. Right, so let's run this again. I was trying to do some debug and that's what I lost only. Okay, now it's even that. I saved it. Right, let's run. Maybe I've done some kind of... Okay, I added some code that I didn't finish it. Sorry about that. NP. Okay, so I was writing some code. For now, I'm just going to do return like this, do nothing. And let's run this again. Okay, I have some. So it's saying that I've made up this function. It doesn't exist. So I need to go to the API. I know there is something for flattening, but I probably don't know that. Okay, I'm going to use my Google skills because I'm pretty sure there's something in NumPy that does that. Flatten array. Basically, I'm just reducing the number of dimensions, and I think actually, now that I say that, there is a... I forgot, what is it? It's like a... anyway, I'll just do it. Yeah, there's a flatten, yeah, of course. So, you see this? Oh, this is... Oh, I just have to call the flatten inside the method. So you see, this is the NumPy array with 2 dimensions, and then it flattens it to what... to basically just make it a single list. And that's what I want to do. And I don't have to... I don't actually have to call np.flatten. I can just do NeuronGrid.flatten. It should work. And I hope it's already in the right shape. If not, I can also do reshape as well. That's another one you can use. Reshape, you have more control. This is great because it allows me to just use some of these NumPy. This type of small, simple exercise allows me to test some of the, understand a bit more like some of the NumPy functions that you might see in some really complicated code and you've no idea what it's trying to do, but here it's quite clear what it's doing. And f string unmatched. I think I didn't close the brackets properly. I have too many round brackets, that's it. So let me just close this. Oh, I think it's crashing again, but it's not a big deal. I can still come back to... Come on. Blender. To be fair, I'm using version 3.0. I need to upgrade to the latest version. It should be more stable. I don't actually know what caused it to crash. There might be some silly error. Died. Okay. I need to put this. We're back. I shouldn't have lost too much actually. So the flatten is here. Okay. And I'm going to run this again. I don't really care about this geometry for now. I just want to see the logs. So Windows System Console. And I can see now that it's flattened, but I think it maybe... Yeah, I think this is okay. I'm not sure actually. This flattened too much. This is not what I want. I wanted to have like a list of coordinates, and each coordinate has 3 dimensions like X, Y, and Z. But this flatten is done, it has put like all the numbers into a big list. So this is not what I want. But I think I just remember that there's reshape as well. So reshape allows me to remove like 1 dimension. Let's go to the API just to be sure. Reshape. So reshape. One second, I have a visitor here. Thank you. Thank you. Yes, it's very nice. Can you go downstairs and... Oh, you can stay here. It's okay. Right. Right, so we have reshape -1. Okay, so we have here np.reshape. And then we have... One second. All right, can you hear me again? Yeah, sorry, I had to mute myself. So I have some visitors here. All right, so we have... So the reshape is the method that I was thinking about using. So if we use reshaping for this array, right? With 6, it's giving me all the elements in one single list. But if I do -1, that should do what I want, actually. Let me just try it. So -1, -1, and all right, so I'm going to run this, and I have hopefully some debug that is going to give me... So I have some error. Order must be str, not int. What did I do wrong? Oh, reshape, and then reshape here as well. Okay, and then... Okay, so we have... Must be str, not int. I think in this case, I have to use np.reshape. So np.reshape. So we have some background music now from my daughter. Hopefully that's not going to get me into trouble with YouTube. Okay. So neuron grid 2. No, okay. I'm kind of... Oh yeah. So first argument is the array, and then second argument is the... In this case, -1. I want to remove one dimension for now. And then the same here. Okay. Okay, it's good. It's very nice. Okay, so let me just run this. I'm sorry for the for the disruption, but you know, that's how it works when you're on a Saturday afternoon coding at home. Right. Okay. Oh, no, don't touch that. Okay.
I did that.
No, please. Okay, 1 second. Oh. Sorry. So yeah, I see you are asking questions in the chat. I didn't see it, but give me a second. I'll be back in a second. Yeah. Can you still hear me? Oh no. I was on mute. Oh. Oh. It's okay. I think you got it, right? Yeah. I put myself on mute without realizing it. I unmute. Okay. Right. You can hear me now. So what I was doing is okay, object, you see? It has an example here. ppy.context.object. Yeah, a bit annoyed because if I've been talking for like 20 minutes and you haven't heard me. But I guess I'm not saying anything useful. Okay, so that's it. I think this is a fix. Right, we have so there should be. I'm going to delete everything and then try again with. I'm just going to call this multiple times to make sure that it still works. Doing, you see, it's actually, I think it's working, but like, why is the first one bigger than the second one? The second one is bigger than the first one. I think it might be because I made it bigger. Okay, right, this is kind of, it should hopefully work. Then I'll, okay, let's see. So connect. Okay, let's try it. Did I get an error somewhere? Where's the cylinders? Wireframes? There's nothing hiding. Did I? Where's my connect layers? Okay, I didn't comment back in. Okay, so let's try again. Fingers crossed. It will be so nice to actually have something that kind of works. What is this? It's not exactly what I planned to do. Okay, so it seems like it's completely wrong coordinates. Why? So this one is. Oh, okay. Maybe the angle is not big enough. Okay. So once again, I have too many to try. And the question is, which one is not working? Is it the coordinates that are wrong, or is it the actual cylinder that's... Okay, so I need to probably have a bit more confidence on that method first. Okay, let's see. I'm just going to make it completely random and see how it behaves. Let's do... Okay, so I have these two. This, let's call it pipe. And let's see if the coordinates are correct. So the actual starting coordinates is supposed to be 3, 1, 0. It's kind, I would say it's kind of accurate for the start. And then for the end, it's 2, 2, 2. 2, 2, 2. Yeah, I think this is good. So let's say, let's start with I'm going to make this higher. So 3, 3, 3, 1, 3, 2, 2, 2, 2. Let's run again. Okay, so this is what? So this is 2. It's not really like clear what it is. So 3, 1, 2 almost, but this is not exactly the coordinates that 3, 1, 3 and 2, 2, 2. Okay. So 3, 1, 3. I think it's hard to judge because there's multiple points. Okay. And then 2, 2, 2. Yeah. This is actually, I think there's something wrong with this method. Okay. And I need to figure out what is. There's something here that's not right. I think it doesn't work for, if I swap this, make it 2, 2, 2. Okay. I'm going to run this again. There's no errors. One. I really don't know. Yeah, 3, 1, 1, 2. Yeah, so it breaks somewhere. I need to look carefully at this method to see what it could be wrong. So the midpoint, it calculates a midpoint. The midpoint is a method I call here. So the idea is to, you give a location start and a location end, we find the point in the middle, because we know the cylinder is going to be created there. So I can actually check, first of all, if that's working as expected by stopping just before it does the rotation. Okay. So the midpoint, I should be able to calculate it myself as well. So I can see it's vertical, and the midpoint of this is 2.5, 1.5, 2.5. No, make it like 2.5, 1.5, and 2.5. And if we look at the actual coordinates I gave it, this is one point and this is another point. So to calculate the midpoint, we basically take the two locations, we sum the two coordinates, and we divide it by 2. So 2, what is it? So 2 plus 3, 5. 5 divided by 2 is 2.5, right? Then 2 plus 1 divided by 2 is 1.5. And then 2 plus 3 is 5. Divided by 2 is 2.5. And if you look at the actual what is it? Modeling. This is actually where it is, yeah? Always goes into edit mode for whatever reason. So we have our cylinder here in the vertical, because when you create a cylinder in Blender, it will create one which is vertical. Basically, vertical here is the Z axis. So, and the reason why we have to rotate is because we need to point it towards so it matches the points that we want. Okay, it should already have the right length. Okay, and what doesn't seem to be working is the actual rotation. So if I add the rotation, it should be, the midpoint should actually stay the same. At least that's what I expect. So let's just check that, right? So before I do anything here, you can see that the object has this location. After rotation, it should still have the same it should still have the same location. So I'm going to comment this back in again and run it. And let's go to the modeling, and the location is still the same. The rotation is there now, okay? But obviously, either the length is wrong. So let's see if it falls short. So the lowest point that we expect to see is this. This one is the lowest point. So the lowest point should be somewhere here. So it's going to be this point here, but because this is a cylinder, all these vertices are around that point. So the lowest point is actually 1.6. So I think it's too, it's going more down than it should go. Maybe the rotation is not enough, I don't know. Is it too? Should be a bit higher, yeah? So this should be, maybe the rotation is too much, maybe. Okay, but I can also find out from the highest point. If, so 313, and we have here 312. Sorry, that's z equal to 3. If it goes even higher. So it's actually bigger than it should be. That's what it seems to me. So if it's bigger, let's hope the angle is right. So 3-1 should be 313 roughly. No, this one 222. 222, but it's below that. But maybe that's okay actually. 222. But it still doesn't explain why it was so bad, the final results that we had. Unless those coordinates were completely wrong. Okay, let me just go back to what we had before. Even though there's something wrong there, those dimensions are not exact, or it doesn't look like 100% correct. I'm still not sure why. The actual result is too, I think it's a more basic error. Maybe these coordinates are correct. Just that. So 2. If I take one of these and rotate it, it's kind of, it's almost right, isn't it? I do it by hand. Oops. So I do something by hand, something like this. I think it's the right length. It's just the starting and end coordinates are completely wrong. And let's just go back to our basics, right? So this is the location, 0, 0, 0. And then what are the actual coordinates that we calculated for this? Let's see. So I'm going to print this again because I need it. Yeah. Now I'm going to run it and I'll check the debug. And we can see that we have about so these are the coordinates that we get. But are these anywhere close? Okay, this is the closest we have, 0.5. Oh, look at 10. Yeah, but 10 should be the y-axis. But is that correct? Let's find out. So let's just I'll check here. So the 10. Okay, that's correct actually. So 10. Should be okay. Okay. Now we have 0.5 and 1.5. So minus. Oh, wait, hang on. This shouldn't be possible, right? No, it's okay. It's okay. It's okay. So minus 1.5. So if this is right, it looks to me like it's okay. Then maybe I'm mixing up some kind of locations. Location and location start. Let's see this. Connect neurons. Yeah. Neurons layer. Okay, so terminal go connect neurons. Connect neurons. I have two methods called connect neurons. Why? Oh, I have a problem here. I have two methods with the same name. How is that possible? I'm sure that doesn't explain. Okay, connect layers and connect neurons is different, right? What's the difference between this one and this one? Oh, okay. This is the wrong. This is a broken method. This is the right method. Just run it again. Try. Maybe I was using the wrong method. I don't know. Ooh. This is, I can't believe it. Okay, we have something. I don't know exactly where these neurons coming from. This guy, I don't know what these ones are, but this looks good. Oh my. Oh, but I don't know. These are like chopsticks coming sideways. Oh, okay. So I don't know where they are coming from, but this is fantastic. Wow. Okay, maybe I delete everything just to be sure this is not from the previous run. Maybe I also added some debug code. That could be the reason why. No, I don't know. Okay, so there's something wrong with it still. But you know what? Like, I'm really happy because I have fully connected. It looks weird though. How did this come up? Where is this coming from? There must be some. Maybe some rotation went wrong or something. Let me see. So each of these neurons should have 4 connections to the neurons here, and we can see that they have 2, 3. No. Let me see. They look like they have 4, but I don't understand. Okay, maybe there is some code somewhere that I need to. Okay, I need to figure out where it's coming from. Those extra cylinders. But it's starting to come everything together, right? Even though we have some really strange. You know what? I think I'm going to finish here because I have to take care of some things. You know, as a Saturday afternoon, I need to finish, right? But I'm going to continue this in the next live stream. I'm going to continue what I'm doing now, and I'll be fixing this. I'll figure out where this is coming from. But you know what? Like, I'm already very happy that this is more or less what I wanted to do. And this method that I created in the previous live stream that connects the 2 neuron to it connects the 2 layers, and this is called the fully connected. They are called the fully connected layers because you can see each of these neurons is connected to the 4 neurons on the other layer. Of course, I've just made the numbers very small to make it easy to get the basic code to work, right? These are fully connected layers. Also, something that I will do later on, I'll make this much thinner, right? It's very thick right now. And I don't know if it's going to make a huge difference in the visualization at the end, but I can also make the thickness dependent on the weights that the neural network has. Yeah. But, you know, I'll fix this back later. All right. Thank you so much for joining this live stream. Don't forget to click the like button, and I'll see you again soon. Happy coding!